What would actually happen if every single person on Earth jumped at the exact same time? This is one of those questions that sounds absolutely wild at first, but when you dig into the physics and the math, it becomes a fascinating exploration of scale, mass, and just how truly massive our planet is compared to the biological life clinging to its surface. To understand the consequences of this hypothetical great global jump, we have to look at the numbers, the laws of motion, and the sheer disparity between human energy and planetary momentum. Let's start with the baseline data. We have roughly 8 billion people on Earth today. While every individual varies in size, let's assume an average human mass of about 62 kilograms, roughly 137 pounds. When you multiply 8 billion people by 62 kilograms, you arrive at total human mass of approximately 496 billion kilograms. At first glance, 500 billion kilograms sounds like a staggering, world-altering weight. It is a number so large it is difficult to visualize. However, true perspective only arrives when we compare this to the mass of the Earth itself. Our planet weighs approximately $6 times 10 carat, $24 kilograms. That is a 6 followed by 24 zeros. To put this in a more relatable context, if you took all of humanity and placed us on a cosmic scale next to the Earth, we would represent about 0.00000000008% of the Earth's total mass. We are not even a rounding error in the grand calculation of the solar system. We are like dust particles trying to move a mountain, or more accurately, like a colony of bacteria trying to push a skyscraper. Imagine we could actually coordinate this. Every single person on the planet somehow receives a message. We sync our watches, and we count down together, 3, 2, 1, jump, at that exact moment. According to Newton's third law of motion, for every action, there is an equal and opposite reaction. As your leg muscles contract and push down against the soil, the asphalt, or the floor, the ground pushes back up on you with the same amount of force. This is what launches you into the air, usually about 30 centimeters for the average person. So, we have 8 billion people all exerting downward force simultaneously. You might imagine that this concentrated burst of energy would create a massive shockwave or a global earthquake. In reality, the force is distributed across the entire surface of the inhabited world. Humans are not evenly distributed. We are clustered in dense cities and spread across disparate continents. Because we are jumping from different points on a sphere, many of the horizontal components of the force would actually cancel each other out. Seismologists have calculated that the energy released from such a landing would be roughly equivalent to a magnitude 4 to 7 earthquake, depending on the concentration of the crowd. While a magnitude 7 earthquake is powerful and can be destructive locally, it is not a world-ending event. In fact, earthquakes of various magnitudes happen somewhere on Earth every single day. The planet is well accustomed to absorbing such vibrations. The thud of 8 billion people landing will be a massive acoustic event. A collective roar of feet hitting the ground that would sound like a rolling thunderclap, but the crust of the Earth will remain intact. The most persistent myth about this experiment is that it could knock the Earth out of orbit. Let's look at the law of conservation of momentum. When we all jump up, we do technically push the Earth away from us. However, because the Earth is so much more massive than we are, its movement is infinitesimally small. Calculations suggest the Earth would move downward by about 1/100th of the width of a single hydrogen atom. This distance is so microscopic that it is essentially zero for any practical measurement. Furthermore, gravity is a two-way street. As we are in the air, the Earth's gravity is pulling us back down, and our gravity is pulling the Earth back up. When we land, the Earth returns to exactly where it was before the jump. The net change in the Earth's position, its orbital path around the sun, or its axial tilt is absolutely zero. It is like a passenger on a massive cruise ship jumping up and down in their cabin. The ship might technically experience a microscopic vibration, but its course through the ocean remains entirely unchanged. To further illustrate the scale, consider the energy involved. The total kinetic energy of 8 billion people jumping will be somewhere around 200 trillion joules. While that sounds like the yield of a significant explosion, we must compare it to the Earth's own energy. The rotational energy of the Earth is approximately $2.60 times 10 carat 29 dollar joules. Our collective effort is like trying to stop a speeding freight train by throwing a single feather at it. The atmosphere would also play a role in dampening the effect. The air is a fluid, and the pressure wave created by the jump would dissipate almost instantly into the surrounding environment. Some theorists wonder what would happen if we all gathered in one spot, say a massive field the size of Rhode Island, and jumped together. Fitting 8 billion people shoulder to shoulder would require an area of about 1,000 square kilometers. If we all jumped in this concentrated formation, the local effects would be much more dramatic. The seismic impact would be concentrated in one tectonic area, likely causing buildings to sway and windows to shatter across that specific region. It would be a terrifying experience for those in the crowd, but for someone on the other side of the planet, the event would barely register on sensitive scientific instruments. What is truly fascinating about this thought experiment isn't the physics of the jump, but the logistics of the coordination. To get every human being to act in unison would require overcoming every barrier we have: language, politics, religion, and technology. We would need to reach remote tribes in the Amazon, researchers in the frozen wastes of Antarctica, and sailors in the middle of the Pacific. We would need to sync time across every time zone with millisecond precision. In a way, the act of getting 8 billion people to agree to do anything at the same time is far more powerful than the jump itself. If we had the collective will to coordinate such a feat, we would likely have the collective will to solve climate change, end poverty, or colonize other planets. The jump is a physical non-event, but the coordination would be a turning point in human history. Ultimately, if every person on Earth jumped at once, the Earth would not notice. The planet has endured asteroid impacts that released energy equivalent to billions of nuclear bombs. It has survived the shifting of tectonic plates, the eruption of supervolcanoes, and the crushing weight of ice ages. A few billion primates hopping 30 centimeters into the air is, to the Earth, less than the buzzing of flies to an elephant.